We are free range math students. We're cageless here. All right. So I'm gonna start with this concept called a variable. Have you got blocks?
Yes, I do actually.
All right. Cool. What kind of blocks you got? Let's see them.
I have basically 1 to 100.
Oh, let see. Let's see your kit or whatever you got.
We
Your
got,
box or whatever it is. Just hold it up to the camera.
little block.
Yeah, those are exactly them.
Yeah.
Yeah. Okay. So those are. Are they? Hold it closer. Hold the 2 up, and I will tell you what kind of. All right. Those are MUS. I know what those are. All right. Fine. They will work fine. So what you need is the big red square. You're gonna need one of these in a minute. But let's just start off with. See this one right here? Grab this one.
Yeah, I do.
Okay. All right. So you notice that on those, one side has like all the little holes in it. One side is there. Okay. So that would be the side that's negative. This would be the side that's positive. And then on the smooth side, see it's nice and smooth. Okay. Algebra is a smooth subject, right?
Okay.
And we're on the smooth side, and whoever's talking in the background is coming right through the microphone. So.
Oh, is it too much? Okay.
Can they go in another room?
Pardon
me, I'm trying to do math. Excuse me, trying to do math over here.
Okay. Sorry about that. It said my mom's on a business call.
Yeah, there you go. And you're all in the same room because the computer and stuff.
Yeah.
Yeah, I get it. And on top of that, yeah, exactly. I know, dude. You want to know what a small apartment is? I'll take you around mine afterwards, and I'll show you how small it is here. Because Brooklyn and Maui, that's something we got in common, right? And you're probably paying out the yang for it on top of everything else, right?
Forget about it.
Yeah. Anyway, all right. So, but yeah, see, I like having students from all over. I got students from Chicago and New York and Virginia and Dan, all over the place. And see, that's what you communicate, and you realize, oh wait, pretty much everybody's the same, right? Anyway, all right. So anyway, this is the smooth side, and on the smooth side, we don't know how much it is, okay? Because what we're doing is we're just using our imagination, and Einstein told us imagination is more important than knowledge, right? Okay. Always changing, always varying. Your camera keeps dying, and when it's always changing and always varying. We call that a variable. What shall we name our variable?
X.
You like it, I like it. X! There's on paper X. Any little kid can do that. But out here, that's an X. Alright, so if I have an X and another X, how many X?
2X.
2X. There you go. Oh, wait a minute. Is it an X squared?
Oh, no, it's not multiplication.
It's not multiplication. I'm just saying, look, I got an X and another X. See, and that's a very common thing, right? I mean, something should happen here, right?
Right.
But what we're talking about is one X and another X. Right? So just 2X. There's no squared, there's no, right? There's no multiplication going on. And it's, just think about it this way. You're sitting in your one chair in your one room in your one house, and you open the one door to your one apartment building after you got out of your one car or off the one subway train or whatever it is, right?
Right.
No, you never say that. So we just call it X. We don't say one X. We just say X and another X.
Right.
Okay? So, see the most dangerous word in mathematics? The one is understood. Well, no, it's not. Right? I've had college students go, well, right? They don't know what to do.
Right.
Or they'll put a 2 there or something. Okay, now grab your big red one.
Okay.
Because you've already fooled around with these guys, right? So you know these are just units. These are just 1, 2, 3, 4, 5, 6. Okay. So grab that big red one. Now, the only issue with that one is it's supposed to be smooth, but you don't need it. We're just going to use our imagination, and we're going to say that on the smooth side... Do I really not have one handy that's smooth? Yes, here we go. On the smooth side... Right?
Okay.
This is yes, there you go. Exactly. Well, it can't be that because it's too. That's actually your X.
Okay.
Right.
Well, imagine this side is the
just imagine that this is smooth. Just pretend. And what you'll see is that it's X by X. This is also an X. What shall we call this?
Y.
What shape is this?
Oh, well, it's a square.
And if it's also an X, let's call it X square.
X square.
What do you say?
Okay.
Are you agree with me? We're good?
Yeah.
Okay. And look, I'm not going to run down the Hermetic Principles path with you, but it's all imagination. It's what we're thinking. We can call this anything. You could call it Bob if you wanted to, but we're calling it X squared.
Okay.
All right?
Mm-hmm.
Now we need a symbol for X squared. X two ways. X two ways. So if I have an X square and another X square, how many X squared do I have?
2x squared.
2x squared. And I've had college kids say, well, how come that's not a 4? And where did that 2 come from? And Dad, this is stupid. Okay, no, actually it's not. You just didn't understand some very basic principles.
Right.
Oh, and that's the other thing. Before we even get down this road, we're going to have to cover some basic concepts. You brought pencil and paper, didn't you?
Yes, I do.
All right, because you'd be amazed at how many kids show up. I got my computer. I don't know. No, you need pencil and paper.
Right.
All right, excellent.
Yeah.
Excellent. Is it graph paper?
I have graph paper underneath me, yes.
All right, you probably won't need it, but just in the future. Yes, excellent.
Just in case.
Just in case, exactly. All right, so now we've got that introduced. So we know this is, what's this thing called again?
X squared.
X squared. What's this?
X.
Okay, can you show me your X squared?
Okay, so we got X squared.
That's your X squared. We're just gonna, like I said, we're just gonna pretend that side's smooth. We're good.
Okay.
All right.
Right.
And then, and those are X. Okay, excellent. All right, so simple. It's no fun playing math if you don't know what the pieces are, right? Okay, so I'm gonna start off. Actually, before we even do that, we're gonna start off with X squared, 3x, and 2, and you're gonna factor that. Have you done factoring?
Yep.
Factoring of polynomials. Have you used your?
Trying to remember.
Yeah, there you go. Have you used your blocks to do factoring?
Never.
Yeah, see what I mean? Oh, you're gonna love this. I'm serious.
Okay.
You're gonna love it. You're gonna be like, can I come twice a week instead of just once a week? No. Let's see here. All right, so get your paper and pencil out.
Okay.
And what I'm gonna do is we're gonna cover 5 basic concepts. How much have you spent time on my website at all?
No, I haven't.
All right, I will send you links after this, like I said, for you to peruse, and you can watch videos in your spare time, and that's going to be your homework, just watching goofy videos of me fooling around with kids playing math. And you get some ideas. Yeah, exactly. Non-threatening.
I'm done.
Yeah, good. I'm glad. And then, and what grade are you supposed to be in?
10th.
You're supposed to be a sophomore. Excellent.
Yeah.
And then your mom pulled you out of school because of all the nonsense that goes on in schools? Or... Yeah, there you go. We'll leave it at that. Okay.
Yeah.
And plus, Brooklyn isn't exactly known for being like the, safest, most tranquil place on the planet.
No offense to it, but yeah.
Same thing. Well, people don't understand. Here in Hawaii, it's lovely, but our schools are rough also, right? I mean, they're rough, right?
Mm-hmm.
So anyway, and you don't look like the type. So anyway, that just the idea being is that why do you want to do that? You're supposed to be trying to get educated, right?
Yeah.
Okay. Oh, and that's another thing. What kind of aspirations you have? You have any idea what you want to do in the future? I mean, you're only sophomore. I'm not saying you could change next week for all you know, but anything you kind of sort of interested in?
Well, right now it's looking like computer programming.
Well, then you're going to need a little bit of mathematics and some logic and reasoning, just saying.
Yeah.
You like coding? Because I just spent 10 hours yesterday coding. It's not my favorite thing.
Coding. I'm not very good at it yet.
Well, you're so what are you, like 15?
Yeah.
Yeah.
No, I'm 16.
Okay, 16. So yeah, you can get good at coding in the next 8 years. But if you have that, I mean, I know guys that love coding, love it. Like they'll code for 20 hours and then take a nap and then code for 20 more, right? I'm not that kind of guy. I can code, but I'm not keen on it. And all I do is like basic, like HTML and really simple stuff. But the idea is that you only need some math there. All right, so write this down. Because you're, like I said, because you're brand new, and this would be great. I'm recording this, but I'm not recording you. I'm just recording the board, what you're seeing over here, right? And that's the other thing.
Okay.
If you can't see, or if it's, you know what I mean, like if I'm off or something, let me know. Because a lot of times I've got a couple of cameras going. Well, I got that camera and this camera going, and the important camera is the one you see, not the other one, right?
Right.
Okay. All right, so, and even though I'm up here, I'm going to write over here. So concept number 1. What are we doing when we do math?
Oh, we're changing.
Yeah, try not to be that. Okay, you're 5. What are we doing when we're doing math?
We're doing something to numbers.
There you go. Something to do with numbers. What are we doing with numbers? What's the only thing we can do with numbers?
Manipulate them.
Okay, I like the fancy use of English there, but again, you're 5. This is 11 years ago. Go back in time.
Okay. Change numbers into or get a answer out of numbers or something.
Something like that. How about this? How about this? Math is counting.
That's true.
All right. Math is the study of numbers, and that's all we can do with numbers. This is why I want my boy to do penmanship right here. There it is, proof positive. Because I was a bone when I went to school and didn't pay attention and I was rowdy and yeah. Now look at how well I write. Oh look, I know I've seen teachers that write on the board and it's beautiful. But you can pretty much make out what it says. So math is the study of numbers, and all we can do with numbers, not hashtags, is count. That's it. So when we're doing math, we're counting. We can count angles, we can count degrees and angles, we can add 2 numbers together, right? And certainly we can use manipulations to make it easy to count. We're going to use rectangles to facilitate counting. We'll talk about that in a minute. But we're always counting something. We're counting miles, we're counting feet, we're counting something. We're counting ounces, right? That's measurement. We're counting something though. So when you think of a problem, what are we counting? Right?
Numbers.
Right? Okay, right. And that's what I mean. When it comes to say I do something like this, I'm going to do this in just a second. What are we counting? We're counting how many 12s are contained in 132.
Right.
We're counting 12s.
Mm-hmm.
And I'm not going to get too crazy on you because you're a student there, but the bottom line is, when you get right down to it, it's amazing what we can do with our mathematics, and all we can do is add. We can add a negative. We can add it over and over again. We call that multiplication. Or in this case, we can keep track of our multiplication, how many times I multiplied this number, right, and subtracted. So how many times we added a negative, and we count that, and we call that division. Okay, so those are the 4 basic operations: addition, subtraction, multiplication, and division. We can do that with whole numbers. We can do it with fractions. We can do it with decimals. We can do it with radicals, right, square roots and so on. We can do it with all manner of things, but we still have 4 basic operations. This many, right? And then we apply those 4 basic operations, which is basically just adding, when you get right down to it, to everything. Right?
Right.
Okay.
Mm-hmm.
Are we good with concept number 1? We're just counting.
Yep.
All right.
We got it.
Concept number 2. And then we're going to dive right into algebra, because you know what? Algebra is just counting. I do it with 5-year-olds, it doesn't matter, right? It doesn't, I mean, like, we could start with division, we could move up to trigonometry, whatever, right? It's just counting. Right?
Gotcha.
I mean, it's a level playing field in a minute, you'll see. But all right, so concept number 2. In this one place, and this is huge, in this one place, how high can I go?
That one line?
Yeah, just that one place. Like, this is places where, digits. If I have one place, how high can I go?
Infinite?
Really? Can I go infinitely high in that one place?
Oh, you mean like in that...
1, 2, 3, 4, 5, 6, 7, 8, 9. And if I add one more, what do I get?
Oh, it's the fraction. Okay.
Gotcha. Oh, not even a fraction. I'm just saying it's a place value. How high can I go?
Oh.
So yeah, I love it. I already can tell. So you have been put upon to the point where it's supposed to be complicated because we're doing math, right? Okay, get rid of all of that, right? You're in the house of math now, boy. So it's all gonna be simple, right? Okay. Never gonna make it hard. So quit trying to make it complicated answers and try to, right? Just keep it. Just like I said, pretend you're 5. Just pretend you're like a little kid. All right. So how high can I go there? I can go 9. If I get 9 together, here's my 9. Right? There's my symbol for 9. If I add one more, well, I need 2 places. It never gets past 9.
Right.
See, and that's why I need to have the camera on so I can look at your face and see that, like, you just went, oh, right? Okay. All right, now, if I get 9 of these guys together and I add one more, 990. Let's see here. Do I have one handy? Yes, I do. There's 90 of them. And I add one more, and I get 100.
Right. Yeah.
But it never gets past 9, does it?
Right. Because you have to
Which is why we call this base 10 mathematics. But yeah, that's it. It'll never get past. It'll never get past 9. Look, I have thousands. When I get to 9,000s, then I'll get to 10,000s. That's the name for it. And then I get 10,000s, and then I get 100,000s. But it never gets past 9.
Right. It goes 1 to 9.
Right. This is hugely important, right? Because we only got 0 to 9. That's all of our digits. That's it. Right? Arabic digits. Okay. So, before we can count, though, I got ahead of myself. What allows us to count? Now, here, I'll give you a little question here. So here, don't just call them pink ones. You don't have to call them 3s. I know you know they're 3s because you've got these blocks. But and then I got a couple of these and a couple of those. And there. All right. So now we're going to differentiate by color. You're not colorblind, are you?
No.
And it's kind of, oh no, because I mean, dude, you'd be amazed. I work with all kinds of kids, and colorblind is a lot of colorblind kids don't want to tell you they're colorblind. But anyway, all right.
Yeah,
so
no, I'm fine.
All right. So how many pink ones?
3.
How come you didn't count those because they're not pink? Okay, wait.
Right.
How many green ones?
1.
Okay. How many orange ones?
Unless you count those as orange.
Yeah, well,
those are 2.
There's just 2, right? Like I said,
Yeah,
oh
orange,
man, see,
yeah.
I can tell. You had teachers that tried to trick you in mathematics constantly, didn't you? Yep.
Yeah.
Yep. They're constantly, right, because they want to show they're smarter than you, and they want it, right? And they got to put you in your place, and they always trick questions. Okay, not going to be any trick questions. Those are orange, period, right? Okay, how many? See, that's what I mean. I know it, I can see, right? I've been doing this, this month makes 30 years of doing this, right? Spend 2 minutes with you. And if we're in person, I could tell you if you're kinesthetic, auditory, or visual, but I'll figure that out between now and the end of this lesson. But anyway, the idea being is, let's see here, how many total now pieces?
How many? It's 6.
There you go, right? Why? Because I made them all same. Now I just said how many pieces. I didn't say pink, I didn't say orange, right? So what allows us to count? And this is a huge concept again, huge. They have to be same, right? Because if they're not same, we can't count them, right? You say same, I'm sure, but I mean, it's same. They're same. If they're not same, you can't count them. Right? If we're counting people in a room, we can count everybody. But if we count boys in the room, now we can only count the boys. And usually, now you got to define what's boy. Usually between, under 18. How many girls? How many men? How many women? Right? Now, if we count people, we can count everybody. But they have to be same before you can count them. So, like, when I have a problem like this, that's supposed to be a 2. Can we count those? Can you add those 2 together?
Yeah.
What do you got if you add those 2 together?
2, 5. 2 over 5.
Okay, see? It's just 2/5. I got a problem with that because you know what? This is one of the halves kind and one of the thirds kind. That's not going to give me 2 of the 5ths kind. But let me. Oh no! Oh no! My fractions pieces are not here. Uh-oh. I know exactly where they are, though. So we're going to have to take a very short, brief pause while I run down a hill to my car.
While you do that, I'm going to plug my phone in so it doesn't die.
There you go. Excellent. See, both of us. All right, so brief pause.
Okay.
Brief pause. Brief pause. Pause for the cause. Okay. We're back. And I need to... There you go, now we're happy, jeez. Okay, so, one of the halves kind. Wait, so here's what we're gonna do. We're gonna take your big one, Oh, jeez, this guy's been beaten up. This is supposed to be a solid green thing, but it's gotten a little old. Anyway, all it is blowing this thing up. So what I have here, do you see I have half of it?
Mm.
All right. So there's a half. Now I'm going to take the same one. I'm just going to break it into. Oops. Just going to break it into. Oops, 3 pieces. Oops, that's not the one I wanted. That's the one I wanted. 3 pieces. So now this would be 1 of 3. So here I have 1/2 and 1/3. Do you see it?
Yep.
Okay. Now 1/2 and 1/3, when added together, is never going to be 2/5. See, this is a fifths kind here. This is right. It takes 5 of them to get in there. There's 2, 4, and 5. So fifths kind.
Right.
Okay. So, Same. This is where we right. This is same. Okay. These are not same. 1/2 and 1/3 are not same.
I see.
Right.
Yeah.
So I can't just go. I can't just right. And this is the thing, right? Kids will be like, "Well, the rules changed." The rules did not change. Right? Before I can add these, okay, you know what? And it's no fun. You know what you gotta do? You gotta go back to 1. So what I'm gonna do is, I'm gonna multiply this by 3/3, and I'm gonna multiply this one by 2/2. Okay, so what I'm gonna do here is I'm gonna draw a picture of this, and I'm gonna use black. Alright, so here is one of my halves kind, and here is, oh, I'll just do that, one of my halves kind. And then here is one of my thirds kind, and these boxes are supposed to be identical and exactly the same, and I can't do it because I'm not that great of an artist. Ugh, okay. Pretty much the same. And now I gotta figure out, well, let's see, if I do 3/3 on this one, and then I do 2/2 on this one, now I can see that over here, what's 3 times 1? Well,
3.
3. What's 3 times 2?
6.
Isn't 3/6 the same thing as a half? You see I have 3 of 6 there? That's still just half of them. And over here, I'm going to have 2/6. Oh dear. That's just cool. I'll be able to record this and you'll be able to show your mom. Or your dad, or whoever's there. Alright, and boom. Alright, so now you can see that that's not equal to 2/5 at all. What I have is 1, 2, 3, 4, 5. 2 plus 3, right? 3 of the 6 kinds, 2 of the 6 kind, 5 of the 6 kind.
I see, they're the same.
Yes, and you know what? This is awesome because you will be my motivation for getting my fraction page finished. Because I've been saying I'm going to get my fractions page finished for like, I don't know, 3 years now, and I still haven't got it done. So, but I got close. But I've had some issues on my website that are very annoying because I didn't cause these issues. The compiler did, and they right, because there's a they went from HTTP to HTTPS to secure, right? So all the pages that don't have the S there are broken links now, or your browser won't go there because it's not a secure website, right?
Right.
So, oh my gosh, that's causing all manner of, I gotta fix all of these, and then I got broken link, and anyways, it's, God.
Yeah.
Alright, so that's what I was doing for 10 hours, it was literally finding and putting in S's. Anyway.
You gotta write all of those down or else...
Yeah, I know, oh my goodness.
There. Yeah.
Yep. So anyway, and then I compile the page, and when the page compiles correctly, I know I found all the S's. If I come up with an error warning, I'm like, okay, I gotta find another one. And then I had some other small issues also that caused because then the links broke and oh man. Anyway, so it was just and some pages is you know what, screw this, I'm just gonna build it from scratch because you know what I mean, it's just too much issue. And especially if they had videos in there, it wasn't linking to YouTube and oh my god. Anyway, so but I'm 99% finished with that, and now that I'm finished with that, I'm gonna have a fractions page, and many of these lessons that I'm doing for you I've done many times, and you can just watch videos, and then we'll go over them together.
Cool.
Alright, so, this makes sense though? Same. Concept number 2.
Yep.
Alright, so we can't just stick them together. We gotta make them same first.
Right.
Okay, so this is again basic operations with fractions. If I had 2/3 and I did this, now I can, and now it's easy. If I have 3 of the halves kind, minus, right, and this is basically just starting off the same. Like if I had 1/2 minus 1/3, well, that's pretty easy. That's just 1/6, right? And we can multiply them and divide them and stuff like that. We'll get to that another day. All right, so that's just, see, it's good. I've discovered that. All right, so concept number 1 was math is a study of numbers, and all we do with numbers is count. Concept number 2 is we only count as high as 9, and we only count stuff as same. Concept number 3, as you just saw, is we form, actually I'm just going to draw this. We make rectangles to facilitate counting. We form rectangles to facilitate counting.
Okay.
That's it. So just draw a rectangle and say, rectangles make it easy to count. Something like that. Put in your own words.
Okay. Okay.
Right? Because look, if I have all these guys like this, I got this over here, and I got that one over here, and I got that one over here, and I got that one over here, and I got this one, and I got that one, just because I have 3's handy. Well, if you can count 3, 6, 9, 12, 15, but you know what? Bam. If I turn it into a rectangle, and then I can, let's make it a nice rectangle. There you go. And then I can measure. I'm going to say I have 6 of them there. So I can, yep, I do. 6 by 3, boom, 18. Done. Right?
Yeah.
Okay. Rectangles just make it easy to count. So, and if I have 18 in my rectangle, and I tell you that one side's 3, what does the other side have to be?
It has to be 6.
Can it be anything else?
No.
This is why we love the mathematics. Because it can't be anything else. When you have kids, right? It was that way yesterday, it's that way today, it'll be that way tomorrow.
Right.
Right?
Mm.
Boom. Okay, no, and if I change it around, what if this side's 6? What does the other side have to be?
It has to be 3.
Right? And I can say, what are we counting? We're counting 6s. And I can say that I don't have any 6s up there. Do I have some over here? Well, yes, I do. Get over here. Oh, except for the minor detail that they don't have magnets on them. These kids nowadays. Can you see them? The magnets are just, because gravity is so weak. But anyway, let's see here. Alright, so, there's a 6. No, there isn't. There's a 6. Fine, go over here. I'm gonna glue that up. There's a 6, and there's a 6. Can you see that there's 3 of them in there? One,
Right.
1, 2, 3. That's what we're counting. If it's 6 across, it's 3 down. We're counting 6s. That's all it is.
Yeah.
Ugh, right?
Yeah.
Yeah, I can see, right? Okay, we'll pause because this is going to become overwhelming. It's like chocolate cake. You're like, oh, we love the chocolate cake. And then you eat too much chocolate cake and you're like, I don't eat any more chocolate cake. But I can see that many of your preconceived notions that you've been harboring since you were a little boy are starting to fade away very rapidly. All right. And just like I said, I should put a camera the other way because the expression is awesome. So see, that's what I mean. The eyes tell the story. You're like, oh, right? This stuff's easy. I'm telling you. They tried to make it hard on purpose. They didn't make it hard by accident, right? They try to make it hard on purpose. All right, so I'm demystifying it rapidly for you. All right, so are we good with that? We make rectangles to make it easy to count. That's it. In a minute, we're going to factor from polynomials, and that will make it easy to count the polynomials. All right, with that much math, dude, I can teach you addition, subtraction, multiplication, division, fractions, decimals, a lot of algebra, a lot of trigonometry, pre-calculus, and calculus with just those 3 concepts. But I can't do it all. I need 2 more.
Okay.
And I just got into this the other day. I have this video. I hope I can edit that part in because I was practically yelling at this one student. I mean, in a friendly way. Look, it's all you got. You only have 2 things in your arsenal when it comes to problem solving. And those 2 things are hero 0, right? Your hero 0. Understanding the concept of this thing, 0. And there was a big argument a couple thousand years ago why you need a symbol if it doesn't stand for anything. But no, 0 is your hero, definitely. Okay, and then the last one, and I'm not going to get into examples at the moment. There are many, and we'll cover them in a minute. And we'll cover them in the next 5 lessons for sure. And then the last concept, but I mean, hero 0, he really is. Hero 0. And then the last thing is no fun, get back to 1. That's it. And these are our two.
No fun, get back to 1.
Yep. That's Mui the Moo Cow right here. No fun, get back to 1. Hero 0, no fun, get back to 1. That's it. Alright. If you're going to be doing math, you might as well have fun. Alright, so, Hero 0, no fun, get back to 1. That's it. That's it. This is all your problem solving right here. I don't care if you're doing algebra. I don't care if you're doing trig. I don't care if you're doing pre-calculus. I don't care if you're doing advanced calculus. You've got 2 options for your problem solving. Hero 0 and no fun, get back to 1. That's it. That's all you've got. Okay, now you need to know how to apply them, right?
Right.
Okay, like, I don't know, do you do any martial arts or anything?
Not. I did kickboxing for a little bit, but not.
Okay, well,
nothing.
do some martial arts with somebody that actually meditates before you start class, and they will tell you there are but 5 ways. There is always 5 ways, but there are only 5 ways when it comes to attack or defense. There are only 5 ways. If you master 2 of those ways, you will probably beat all of your opponents. Right? And that's just 2. Okay, if you master 3 of them, oh, you're gonna be pretty rugged. If you master 4, oh man, like, you know, and if you master 5, you're up there with the masters, right? So that no matter how they come at you, you know how to respond instantaneously, and they'll wish that they had never tried. And if you attack them, you have there's only 5 ways to attack. No matter, anyway, that's a whole other thing. But the idea is, here, we have only 2 ways to attack. Hero 0, no fun, get back to 1. If you've got a problem that you need to solve, you've got your choice between, well, you're not going to usually it's not going to be a choice, you're going to use a combination of the 2. Right? You're going to use some Hero 0 and some no fun, get back to 1, and some no fun, get back to 1, and some Hero 0. We'll get to that in just a second. Alright, have you got those 5 things written down?
Yeah.
Alright, so we're going to get to factoring, but being that we're almost out of time already, can you believe an hour's pretty much flown by?
Wow.
That's crazy, isn't it? Okay, but that's what I mean. No problem. I'm going to give you lots of videos that you can watch for homework, and you're there. All right, so you'll see that when time flies when you're having math. And I'm doing math for like the next 3 hours after this. I have students from all over. The next student is from Chicago, and then the next student after that is from the boonies of Virginia.
Maybe that's why you thought I was from Virginia too.
Yeah, somehow I thought it's just because you were East Coast time, and I don't know why that came up, but yeah, I thought you were from the DC area for some reason.
Yeah.
Anyway, but New York's cool. And the cool thing about New York really is if you can imagine it, you can probably buy it in that city. I mean, if you just got to know where to look, right? I mean,
you got to go to the right place.
Whatever it is, you want to, I mean, whatever comes to mind, you can get it. Food, you can eat in a different restaurant 3 times a day for the rest of your life and never eat in the same restaurant as long as you live, pretty much.
Yep.
It's crazy.
Yeah.
I mean, it's just like, wow.
It's a place of variety.
Yes, there you go.
That's what I say is the best part about it, the variety.
The variety is the spice of life, absolutely. All right, so I'm going to give you a problem, but I'm going to use these guys.
Okay.
All right.
Do you want me to use them as well?
Yes, please. Just mimic what you see here. And I'm gonna. You can put 2 3s for an equal sign, but I'm just gonna put my equal sign. Okay, these are all X's. I'm never gonna use them. If they're all the same, they're the same. All right, so I've got, and then I'm gonna do. Let's see here. Oh no, am I out? No, I'm not out. I've got 4. Uh-oh, that's my next student. The answer is leave me alone. Okay, wait, it's chomping at the bit. For Pete's sakes, we got time. Don't worry, we'll get to him in a minute. When the thing starts ringing, then I'll have to go, but we're good.
Okay.
And let's put one more just for fun. All right, and let's decode our blocks because you're a big boy and I can't just start here with you because you need some symbols. Because to you, this is not math. All right, so this is, how many X do I have here?
You have 3.
Okay, so 3X plus 2 is the same thing, not the answer is, right? Equal sign never lies. This doesn't mean the answer is 3X plus 2, right? And see, that's how we say same in math.
Right.
Okay, so 3X plus 2 is the same thing as, you tell me.
Oh my gosh.
2X plus 5.
All right. These are numbers in disguise. Can you solve this problem using your algebra skills? And if you can, that's the whole reason why we're here. But if you can, show me how you do it.
Well, you would use equalization. You would just...
Equalization, huh? All right, cool.
Well, that's the word that we use.
Show me your equalization. Equalize this problem.
So, the way you would do it is that you would get rid of the variables.
All right.
So basically, you would either add or subtract from one.
Tell me what to do. We're good.
So I would add 2 to the 3. That would be 5 plus 2 equals 5. And then I would put the 2 over to the 5.
And then what?
So that would 3. So 5x equals 3. And then it gets fuzzy after.
And then it gets all right. We're gonna make it super easy.
Yeah.
Okay. We're good. Like I said, if you knew how to do all this stuff, why would you be paying me $50 an hour? 60 if you only paid for one. $1 a minute, dude. So yeah, watch me. I'm just about to earn my money. Watch. Do you see stuff that's same on both sides? Because this means same.
Right.
Same. Same. You see that?
Yeah.
And then I'm gonna do same and same. What does x equal?
X equals 3.
Done. Yeah, I know. See, we're gonna, like I said, we're gonna pause. Don't get mad. Get happy. Yeah, it's that easy.
Okay.
Yeah. You stuff your brain back into your head.
I'm good.
Okay. All right. So now let's do it with the symbols because it's that easy. Really, it is that easy. See, and look, your eyes and I see. You're right. Isn't that right? Okay, so there you go. Okay, see all that stuff, all those tears, all that frustration. Yeah, for nothing. People ask me why I'm pissed off, right? Because I'll tell you why I'm pissed off. Because the kids like you. That's why I'm pissed off. Anyway, all right. So let's do it. What we did, you kind of sort of had it, but you kind of forgot the rules and stuff, right? Okay, but now you're always going to remember the rules. Same. 2x, we subtracted. 2x, we subtracted. There they are up there. See them? There's your hero 0 right there. We made 0. Okay, and then... Right?
Yeah.
Okay, and then I took away 2, and then I take away 2, and what am I left with? Well, I've got an x over here, and I've got a 3 over here, and I'm done. Now I can go back, and I can say... Well, if each x, because these x's, they're always trying to trick you. They're always trying to trick you into thinking that they're 10s or they're more. Right? This x was just a 3, right? So if this x was a 3, then let's do it. Let's get all this out of the way here. And what I had was, let's get all these guys out, right? So this was this in the beginning, and this was this in the beginning, and this. But now I know that those aren't x's, those are 3s, and I know that these are 3s.
Right.
And now I can see that certainly 11 equals 11.
Right.
And I can even make my equal sign. Watch me make my equal sign. So when you get done with this, you're going to tell your mom that this is the coolest thing ever, and she was very clever for it.
Oh my gosh.
For taking the leap. Because I know it's a commitment. But there it is. Do you see their equal? That's that equal sign right there.
It's the exact same.
It's the exact same. Exactly. What we had here is when x equals 3, not when it's 2, not when it's 5, not when it's some other number, when x equals 3, 11 equals 11.
Right.
There you go.
Yeah.
That's problem solving.
Wow.
That was super easy for the pot. We're going to do ones when they're negative and stuff like that. We'll get to it, right? I can't do everything in the first hour, but do you see?
Yeah.
Are you starting to get excited and understand that, you can do this?
Yeah.
Yeah, you understand how far up your SAT scores are going to go after about...
now I see that.
Yeah. Okay. Right?
Yeah.
It's not magic, right? I just have good tools that make it easy for you to understand mathematics. Right? And here's the cool thing, dude. You learn this well enough and you start getting on my website and so on, And the second time you pay for a lesson, I'm going to give you all my passwords, and you be diligent, and you can start earning money tutoring your friends. Because guess what? Most of your friends think that 1/2 and 1/3 is 2/5, and most of your friends couldn't solve this problem if their life depended on it.
Yeah.
Right?
Mm-hmm.
If some MS-13 gang member had a gun to their mother's head, they couldn't save them. Like, just solve this problem and I'll let her go. No, you're screwed. Right? Okay, so you can make money and you're in a huge city. There's thousands of kids like you in walking distance. All right.
Yeah.
And believe me, I have had students that I don't know if you like people. You kind of gotta like people though, and you kind of gotta like your fellow man. So
Yeah, I get that.
Yeah, no, you know what I mean? Because like some kid, like if you don't, then not. But at the same time,
no, I feel.
If you do, there is money to be made, my friend. There is huge money to be made because, like I said, there are thousands and thousands of children like you. You need 100 guys like me in New York, right? And that would scratch the surface. How many people in the just Manhattan? Do you know?
I don't know the exact number, but it's a lot.
It's millions.
It's millions.
Right, and what's in the greater metropolitan area? What is it? It's like something crazy, like 20 million or some crazy number like that, right?
Ridiculous.
Yeah, I mean thousands and thousands. So getting a few kids together each week, and then if you're smart and you're not silly like me, you'll have 2 or 3 at a time, not just 1 at a time, and you charge them all the same, right? Anyway, that's later. You want to do coding and chemistry and you want to build stuff? Well, I can help you pay for your education easily. But first you got to learn some math. All right. So, next thing we're going to do. That was just one problem. We're going to do way more problems than that. And if you're on Facebook, like I said, go in. I'll get you a link to my super duper super secret math group, and there's videos there that you can watch. And
awesome.
You'll just have a fun time. All right, so now
I'll totally watch those.
Yeah,
that's awesome.
Yeah, you will, because it's just what we're doing now. Because now you understand the concepts. Now you just change the numbers and keep doing it until you're comfortable with it.
Right.
And you can see how easy that was. And at your age, it'll click together quickly and easily. All right, beautiful. Now get out your x squared. 3x and 2, and our class is coming to an end. Oh my God, they're going to be calling me in a minute. We may not get to this.
Speed run it.
Speed run, that's it. See, very good. That's why you need to be on time or a little early. But all right, I've got x squared, 3x, and 2. Got it?
Yep.
Now here's your job. Turn it into a rectangle.
Turn it into a rectangle. Okay.
All right. So here's x squared plus 3x plus 2. Do me a favor. Can you tilt your camera down so I can see what you're doing on your desk? There you go. Perfect.
I
Perfect.
can try and hold it.
Yeah, that'll distract you. So if you can't, it's fine. But yeah, okay, you got it. And now what you got to do is take these elements and turn it into one rectangle. Yeah, perfect. That's nice. Oh, you got one of them cool keyboards with the colors and lights on it.
Yeah.
All right, so if you do that and that, well, that shape's not a rectangle. You're close.
Right.
Keep going. Ooh, there you go. And then what? And then what? Yep. And then what?
Oh.
I love it. And then where's the other green one gonna go?
Right there.
Bam. All right. Creative thinker. I like it. All right. So what he did is he did this, and then he moved this down, and then he did that, and then he did that. Did you get a rectangle? The answer is yes. You got a rectangle. All right. Dude, okay, so you actually have some aptitude. They didn't kill all of your creativity, which is good. But there it is. All right, so here's all I'm going to do. I'm just going to reshape this rectangle just a little bit. You got it. I'm just going to reshape it so it's easy to count, is all I'm going to do. Just make it easy to count. All right, so I'm going to put this like this and do that. Done. Make yours look like mine.
Okay.
All right, so now I just got all my guys together, right? All right, and now we're just going to count this guy. How far across is this? What's this blue one called again?
X.
Plus how many?
Plus 2.
All right, and this way, how many?
X. You mean on the right side? It's
yes.
X. 2x.
Wait. Just the edge. Just the
Oh, x
distance
plus
from here
one.
to x plus 1. Because here I can show you that anywhere along here it's x plus 2, right? It's x plus 2 there, there, there. Anywhere along here it's x plus 2. See that?
Okay.
And then if I go the other way, anywhere along here it's x plus 1. Right? So the distance from here to here is x plus 1, a distance from here. All right, so you just factored this polynomial, and you told me that it's x plus 1 times x plus 2, because we count the across first, times x plus 1. Does it matter which one we count first? No, because we could have just as easily built it like this. Right? It's the same rectangle, it's just that the factors changed, right? All right, now do you see? There we are, distributing. X times x is x squared. X times 1 is 1. Oh, okay, I gotta do it the way I have it so it works. X times 1 is 1x. There it is. We just distributed this and this. And then 2 times x is that, and 2 times 1 is done. We factored it. Yeah. Again, don't get mad. Get happy. Get happy. Don't be mad.
I'm not mad. I'm not mad.
Okay.
No, my brain is just going all of that time.
Yes. Right? And then them screwing around, like trying to tell you, oh, you don't get this. You must not be smart. Right? Alright. Dude, I've been there. If you think I'm some kind of math genius, you know what I got in calculus?
What?
Didn't even get close. I was getting like 38s and 40s. If I got like a 45, I was like, wow, that was pretty good, right? Okay. Failed it miserably. Now I teach calculus. Right? Algebra, no issue. And in fact, now can you see that, look, if I have a rectangle, and I do, that's x squared plus 3x plus 2, and I tell you that one side's x plus 1, what's the other side have to be? Look at your rectangle.
X plus 2.
Gotta be. Can't be anything else.
Right.
See, now you're doing polynomial division because you can see it.
Oh my god.
No biggie. We got to do the math underneath, but we don't have time today. I'm sorry because we ran out a little
No,
bit.
it's fine.
But boom, there's my picture of it. And all I said was that, look, if that's x plus 1, or excuse me, my picture is wrong. Now I've got it. Got to make your symbols, blocks, and everybody match. There they are. All right, and then that's just this. Ooh, try it like that. There it is. Everybody happy, right?
Mm-hmm.
And we'll get into more detail in next lesson, or you'll find them on my website. But the idea being is that this is easy. This times that equals the whole thing. Always. Just like 3 times 6 equals 18. Right?
Yeah. Right.
That's all it is.
Man.
Yeah.
Okay.
Alright, so you're going to be on time next week?
Yeah.
With bells on?
Mm-hmm.
Alright. Bring a friend if you like. I don't care. But, I mean, that's it. Okay, so, like I said, your homework is going to be to go to my website and watch some vids. Okay, so watch the math vids, just, at your leisure. Don't get crazy and watch, like some people binge watch and they watch like, 50 vids in a weekend. Don't do that. Just watch a few videos, right? Get through them and we'll come back on in a week and we'll do more.
Okay, so will we meet on Monday now or we'll try doing
okay,
Wednesday
we tried to do Monday. Okay, so let's do this time, right? 11 and 12. On Monday.
On Monday. Okay.
Yes. Right? And then we'll do Mondays after this for the guy. For evermore.
Okay.
Alright? I just happen to have an opening today because this other anyway, it's a long story, but the long story short is we got together today, it's no problem.
Yeah.
And from now on, yes, Mondays.
On Mondays. Okay.
Alright. Are you kinda excited that like looking like I can do this?
Yeah.
Yeah, absolutely. Yeah, no, because what did we do? We just counted. Right? We counted one of these and two of those and one of these and one of those. And they're not same, so we called one of them an X, and right? I mean, that's all we're doing.
Yeah.
And that's all I'm going to teach you how to do. And what do? We use a rectangle to make it easy to count.
Mm-hmm.
And a minute ago, we were doing 0, and if back to 1 to solve the problem. Right? Mathematics is study. There's only 5 concepts, man. 5, that's it. That's all you can do. Math is study of numbers. Right? We only count as high as 9. We only count stuff that's same. Yeah, we form rectangles to make it easy to count. Here was 0, no fun, get back to 1. That's it. That's all we're going to do the whole time you ever meet me. That's all we can do because that's as far as we've come.
Right.
You just needed somebody to explain it to you. All right, I'm happy to have met you. And we will play on Monday, same time, same station.
Okay.
All right.
So 4 to 5.
Yes, and check your thing because I'll be sending you, putting links in there.
Okay.
You know, in the little chat box. Right? Okay, cool.
Awesome.
Crewton Ramone's House of Math.com for more.